We want to talk about solving systems of linear equations. Right here we have a system of two linear equations and two unknowns. And in this class we're going to use three different techniques to solve these types of systems. We're going to use a graphing technique, we're going to use substitution in the next video, and then after that we're going to use elimination. Before we use any of these techniques though, I want to kind of get at the idea of what it means to be a solution to a system. So I could ask you the question, is the point 2, 1 a solution to this linear system up here? And when I'm asking that question, I'm asking if we plug in x equals 2 and y equals 1 into both of these equations, are both of these equations satisfied? So let's check it out. The first equation is x plus y equals 3. So that in this case would be 2 plus 1 equals 3, which does check out. If we plug x equals 2 and y equals 1 into the second equation, it becomes 2 times 2 minus 1 equals 0. And that is not a true statement. So since this point does not satisfy both of the equations, it is not a solution to this linear system. Okay, well how about a different point? What if we check the point 1, 2 instead of 2, 1 to see if that's a solution to this system? Okay, so I'm going to plug x equals 1 and y equals 2 into those two equations and see what happens. This point does solve both equations, so the point 1, 2 is a solution to the linear system. Okay, that's great, but we didn't come up with that answer ourselves. How would we come up with that solution to this linear system here? Well, like I said before, there are three techniques. One is graphing, one is substitution, and one is elimination. Graphing is probably going to be the slowest technique, but it does give some insight into why a solution is a solution. So we're going to do that first. What we're going to do is we're going to solve each of these two equations for y, and now we're going to graph both of these equations using our skills with graphing lines. The first line, y equals negative x plus 3, is a line with a y-intercept of 3 and a slope of negative 1. If you need some review on this, you can check out some of my previous videos. The line y equals 2x has a y-intercept of 0 and a slope of 2. And if we graph these two lines pretty well, it pops right out that they have this intersection point. And this intersection point is the point 1, 2. Hey, 1, 2 was the solution to this system of equations in the first place, wasn't it? The intersection point of these two lines is the solution to the system of equations. That's because the intersection point is the only point that falls on both lines. And this concept is the main point of this video. If we understand that the solution to a system of two equations and two unknowns is just where those two lines intersect, then we can follow up with the conclusion that there are three possibilities for solutions to two linear equations and two unknowns. Just like we saw above, if our two lines intersect at one point, we get one solution. However, it's possible that our two lines would be parallel to each other and they wouldn't ever touch. In that case, we would have no solution. The third possibility is that our two lines are exactly the same line and they completely overlap. That means that they would intersect at every single one of these points on this line. There are an infinite number of points on this line. We would get infinitely many solutions. Okay, so hopefully this gives you a good conceptual start to solving systems of two equations and two unknowns. We're going to see how these three possibilities play out in the next two videos. Okay, I'll see you next time.